that first equation, the b value of that first equation.
X equals 1, or the first equation?
Yeah, the top one there. What's the slope? What's the
Oh,
number in front of x?
M equals 1,
Yeah, 1 or 1/1 if you want to do rise or run. What's the b value?
2.
2. So you always start at the b value, use the rise, and then it's always to the right. The run is always to the right. So up 1/1, up 1/1. And you know, if you have a ruler, a straight edge, which I don't, you could graph it like that. So how many points does your instructor want you to graph?
They just want, they want at least 2.
Yes. And so just, do it as whatever your teacher needs. They are grading you. What about the slope and the b value of the second equation?
Slope is 3, and the y-intercept is -2.
Yep, so -2. So you're going up 3, right 1, up 3, right 1. If you do it nicely, you should get a perfect intersection on these. And you do have to indicate the ordered pair of the intersection.
Yeah, I did, and I got 2, 4.
Right. And then furthermore, you could even check that in the equations, like if you wanted to make sure you kept your grade, as high as possible. There's no reason you shouldn't get every one of these correct. Like you can check them all.
Yeah.
But it's a high standard. All right, number two here. If you do the same thing we did there, you're going to recognize the first equation is a slope of 2/1, the b value of 3. Second equation is a slope of 2/1, b value of 1. When they have the same slope, there's two possibilities. They're either parallel or they're the same line.
And this
Since they
one
have
looks like it's
different
going to be parallel.
b values, they are parallel. So start at one or the other. Make sure your lines look parallel. Nothing worse than them somehow converging when they don't converge. I would have a ruler. I obviously don't have one because I actually should grab a ruler. I don't know why I can't do that. Anyway, you might even say that then, parallel, no solution.
Yeah, no solution.
More keywords you give your teacher, the more they're going to think you actually know what you're doing here. Any questions on that before we proceed to number 3?
Nope.
All right. So why don't you try number 3 on your own and let me know your point of intersection when you're done. I'm going to graph it on another screen, see if we get the same result. And small note here on the second equation, you really need to solve it for y.
Yeah. So I got no solution for that one. No intersection.
Yeah, it's the same thing. And then I'll have a good window here, but yeah, you can see it goes. So one's at 4, one's at -4. They just, roughly do that. Okay. Any thoughts on that before we proceed?
No, it was pretty easy.
Yeah, not bad at all. So the next ones you're going to be even faster at, better at. One of the things that might be difficult here for you to do, just because you've seen this stuff before and you're a good math student, you have to do it the way that they tell you. Like, don't do it the way you feel like is right. You have to kind of submit.
Like eliminate. I can't do elimination or anything like that.
Right. Right. So in this one, you're setting them equal. You're putting x -4 in for y or vice versa. But like I said, don't Yeah, especially that gets even better in college. It's even worse. Like you definitely cannot do the way you want. You gotta do the way they say. Um, Real world gets you a little more options. So go ahead and solve that for X, and then we'll talk here.
Okay. I got x equals -1.
Yeah, that's right. So now you put it back into one equation or the other, doesn't matter which one, and get the y value, please.
And y would equal -5.
Okay, and so whichever equation you use, you should try your answer in the other equation, and it should work. If it doesn't work, you made a mistake. Is that clear?
Yep. And
Did your teacher tell you, I'm sorry, one more thing. Did your teacher tell you how to like write your answer? Is what we have here okay, or are you supposed to write it as an ordered pair? Like what do you think?
they want as an ordered pair.
Okay, so that's another little thing, like got to do it the way they want.
Yeah. And then our solution does work.
Okay, for number 5, you have some options here. Uh, Elimination, you need one variable either already solved for or you can easily solve for. Um, since y is already solved for, that's the best choice, but the variable is really treated as in parentheses. So when you substitute it in, you really want to include those parentheses.
Okay.
And you have to apply that negative to both terms.
Yeah, that makes sense. All right.
Let me know what you come up with for x, please.
X equals -3.
So I got x minus 3x plus 2 equals 4. Negative 2x equals 2 and x equals -1. I think maybe you didn't distribute that negative to both. Would be my guess.
No, I did not. Okay.
Yeah. All right, so then you put that back into the equation where you've already solved for y. Like even though you have a choice, there's a better choice.
Yeah. And then I got y equals -5.
Yeah, great. Now you should try that in the second equation. Verify, like you don't want to walk out of the exam wondering if you got it right or wrong. You should know I got them all right when you walk out of this.
Okay. Yes, it works.
Number 6 is like number 4. Why don't you try solving this one on your own? I'm gonna solve it on the other screen and we'll see if we get the same result.
Okay. X equals -1.
Okay, that is correct. Go ahead and find the y value.
Okay. And then for the y value, I got -12.
Good. You can always check that and the other one if you need to, if you're ever, unsure. You might do that at
Yeah.
the end, that way you kind of have a fresh perspective. You're not biased by like, oh yeah, I did it right.
Yeah.
All right. Number 7. Um, this is going to go in for y. And it's kind of like that other problem where you have to distribute to both. That 2 goes to both.
Okay. And then I got x equals -3.
Okay. And then what about for y?
For y, I got just 3.
Okay. And does it work in both equations?
I'm checking that right now. Yes.
It does. Good job. So you're gonna have some questions where you have to do it that way, where you have to do substitution. So do it the way they ask you to. We didn't see any exceptions here, which we might see in the next part. I'll just briefly go through those. So the first exception is like 0 equals 0 or 5 equals 5 or -1 equals -1. When it's the same, that's infinite solutions. Have you guys done that yet?
Yeah.
Okay. And if you get like 0 equals 1 or 5 equals 0 or -1 equals 5, where they're different, that's no solution.
Okay.
You may see that here in the next grouping of problems. So I think you already know how to do elimination. Um, which variable are you going to eliminate?
Um, so I would eliminate this one probably the x's and just multiply this bottom row by 2.
That's right. If you're looking to see that the smaller number goes into the larger number, however you want to say that, yeah, that is correct. So go ahead and eliminate there. Let me know what you come up with.
So for x, I got -2.
But you said you eliminated X.
Oh,
So the
sorry,
one
for
you're
Y.
eliminating goes
Yeah,
away.
sorry, for Y I got -1. And I got ahead of myself.
Okay. I heard two different numbers, so just let me
Yeah,
show you that Y is actually 1.
yeah, that's what I have. I
Okay.
just mixed up the numbers.
Yeah, I know we're late. Yeah, just it's do the best you can. So now you can go back to either equation, but there's a choice. There's like, well, which one's better to work with? I would argue positives are better to work with, so I would use the first equation. Both work though, so you should use the one that you think would be best. Go ahead and solve that for X for us, please.
Okay. And then for X, I got -2.
Okay. So try that in the second equation and see if it works. See if when you put -2 in for X and 1 in for Y, if you get the right answer.
Yes, it gives you the right answer.
Very good. All right. So let's see here. Let's do 11 next because it's more like the one you just did. And then we'll come back and look at 9 and 10.
All right.
So you again have a choice, which variable do you want to eliminate? Uh, there's not a right or a wrong. There's just kind of like better, easier, faster, but which kind of there's, are you drawn to something here?
Okay. So I'd probably eliminate the Y's again, or the Y's this time.
Okay. And you can do that by either subtracting or multiplying one equation by -1. Which way do you see it?
Um, Probably multiplying the first one by a negative to get rid of the negative X variable.
Okay. Go ahead and do that and solve for the indicated variable, X
Okay.
in this case.
I got 6x equals -11.
You said X equals -11.
No, I got 6x equals -11.
Okay. So, sorry, just to clarify here, did you multiply the first or the second equation by -1?
The first one.
Okay. So you got to multiply everything, right? 2x minus 2y equals -6. And you're right, you
Mm-hmm.
get 6x equals -11. So that's okay. So X is -11 over 6.
Okay.
Now, I typically don't recommend this, but because it's easy to eliminate both variables, you don't have to substitute this back in. You could then multiply the first equation by 2, and you get
Oh, and just
minus
do
2x.
elimination again?
Exactly. Now, like most students would never dream of doing this. Teachers probably wouldn't even think to do this, but there's no reason you can't go back and do it that way.
Yeah. Okay.
If you get a fractional answer, consider that approach. We'll save you time, energy, effort, all that. All right.
Okay.
Let's go to number 10 next, and then we'll come back to 9. Make sure you write your answers in ordered pair, which I am not doing. I'll be losing points all over the place. All right. Number 10. which variable are you going to eliminate?
The first one, because it's already done for me.
That's right. That's right. So it ends up being 2y equals -6.
Y equals -3.
Okay. And then which equation are you drawn to solve for x? The top one or the bottom one?
The top one.
Okay. So go ahead and solve for x, please.
And then x equals -3.
So you can try that in the second one to see if it worked. I think you'll find there's an issue with that, a sign error.
I didn't see why I got 1 -3.
So x is 5x equals 5, x equals 1.
Yeah,
Oh, that's what you said. Okay,
yeah.
great. Perfect. So it does work in the second one. All right. Now the reason I held off on doing 9 is kind of the true elimination problem. You can't multiply one equation, you have to multiply both. It's like the final case or type of this. So you still decide which variable. I would recommend looking at the lower coefficients rather than the bigger ones. That will make the multiplication easier. And one of them has to be positive and one of them has to be negative. So your choice, right? Like, um, do you want to make the -2 or -3? Just pick one.
I'll just multiply um the top one by -2 and the bottom one by
Okay,
3.
good. Another small little thing here is that it's good to rewrite them both away from the original so that you're not somehow using the wrong equations. Uh, I didn't say it in the other ones, but you really want to get it away so that you avoid this potential issue. Okay,
Okay.
go ahead and solve that for x, please.
X equals 1.
It's -7x equals 7, x equals negative.
Oh, yeah, -1. Which means y equals 7.
All right, and then you can try that in the other equation. It does work. Um, good. So other than, I mean, a little sloppiness from being tired, I would say you know everything on here. So we've got some time left, of course. What would you like us to do with the rest of the time here tonight?
Um, I feel prepared pretty well for this coming quiz.
Okay.
Um,
All right. Well, we can certainly stop here. I can sort of hear it. Does that work for you?
yeah, that works.
All right. We're gonna go ahead and stop here then.